Okay, thanks everyone for joining us today for our webinar for Signals, the alerting and insight solution for Elasticsearch. My name is Jochen Christin. I'm the CEO of Floragan, the makers of SearchGuard, and I will be your host today. Just a little bit about us. Floragan has been founded in 2012, and we're the makers of SearchGuard, which is an enterprise security suite for Elasticsearch. Our headquarters is in Berlin, in Germany, and we have partner offices in the US, Seattle, New York, Miami, Mexico, and Bordeaux in France. Just a few words about SearchGuard, because I think most of you will know about SearchGuard already. So SearchGuard is an open source security suite for Elasticsearch, which provides several security features like TLS encryption on the transport and the REST layer, which is used for securing all the communication that goes on inside your cluster. We provide role-based access control for your indices and data in your indices with pluggable authentication modules. So you can use industry standards like LDAP, Kerberos, JSON Web Token, OpenID, and the like. SearchGuard can also be used for filtering documents and fields in your search result, which means you can not only protect your individual indices with role-based access control, but actually also control which documents and fields a user can see. We also provide the audit logging functionality, which is mainly used for tracking security-related events, like failed login attempts, for example, or attempts to read data where the user doesn't have permissions for, and also for compliance features like staying compliant with PCI, SOX, or GDPR. SearchGuard is fully integrated in the Elastic Stack, which means we're compatible with Kibana, Logstash, Beats, and also most of the XPack features, like monitoring, for example. And SearchGuard is provided in a community edition, which is free, as in free beer, which you can use for production systems without paying any money. And we have our community and our enterprise and compliance edition, which provide separate or more advanced features like LDAP integration, audit logging, or Kibana multi-tenancy. But in this end, we're Veracode verified, which means that each release is checked for not only our code, but also every third-party module that we use is checked before we release it for security hosts. And we're a member of the Cyber Alliance and the Teletrust, which are two security-related bodies here in Germany. But the main topic today is not SearchGuard, but Signals, which is our very latest feature set that we will release pretty soon. So what is Signals? Well, Signals is, you can view Signals as a kind of a data pipelining for Elasticsearch. With Signals, you can periodically load data from Elasticsearch indices and other sources, then use runtime data to actually work with your data, perform transformations or calculations. You can execute the control flow by using conditions, and then you can store the transformed data back to Elasticsearch or use Signals to send alerts, for example, on email, Slack, or PagerDuty. Signals is fully compatible with all security features that SearchGuard provides, of course, and will also come as a free community edition. Again, this is the same licensing model as with SearchGuard, so you can use it for free, also for commercial and production systems. And we will provide some more advanced features in the Signals Enterprise Edition. So I will show a couple of introduction slides, but the main thing today will be a live demo where we'll showcase 3 or 4 different use cases in order to demonstrate what you can do with Signals. But to start, let's have a quick overview of the general architecture of Signals. So, like I said, on the left-hand side, you have different input sources, which you can use to pull in data to Signals. The most obvious one, of course, is Elasticsearch. So you can run aggregations and queries to pull in data. We also support HTTP endpoints, which you can use to query any API, for example. And in future, we will also add other data sources like relational databases, Kafka, Redis, or the like. So once the data is pulled into Signals, you can then actually work with the data, which means you can combine data, you can transform data, you can implement calculations. This is based on the painless scripting language. And then as a last step, you can trigger actions, which means either send out an alert or store the data back into other data sinks. So the data sinks that we support at the moment, again, are Elasticsearch, obviously, but then also HTTP endpoints via webhooks. And for the alerting part, the initial release will support emails, Slack, webhooks, and PagerDuty. So some use case examples, what you can use Signals for. Well, you can, of course, use it for infrastructure monitoring. The most obvious one is probably log file analysis and system monitoring. So you can check whether you have an increased rate of errors in your production systems, for example. You can also use it to monitor other systems like Elasticsearch. You can use it for security monitoring. You can, for example, combine Signals with the SearchGuard Audit Logging module to detect, for example, brute force attacks on your Elasticsearch cluster. And of course, you can also use it for more business-oriented use cases like KPI tracking, for example, user behavior tracking or CTR tracking. So it actually really depends on the data that you have stored in Elasticsearch and your particular use case. So we need to talk about some terminology. So the first one is a watch. What is a watch? Well, the watch is the top level object of Signals, and a watch is a combination of triggers, inputs, checks, and actions. So a trigger defines when and how often a watch is executed. Then we have a list of checks. Checks are made up of individual blocks like inputs, calculations, transformations, and conditions. Then, of course, we have our input data sources, which we configure. The input data sources put all the data that they pull into a so-called runtime context, which I also show in the demo shortly. So you can use transformations and calculations to manipulate the data. And then you can set up conditions for controlling the execution flow. So for example, you can say that the execution flow should only continue once a certain threshold is reached. And last but not least, we have the actions, which are used to send alerts and store data in data sinks. So how does a watch look like? Well, a watch is basically made up of three parts, which I already mentioned. So we have the triggers, which define how often a watch is executed. We have the checks, which define what the watch should actually do, like executing a search or executing a script. And then in the actions part, you define what to do with the resulting data. There are basically two ways of configuring a Signals watch. Of course, we do support, or we do have a REST API, which you can use to create a watch, to delete a watch, to start and stop a watch, and things like that. So you can use the REST API, for example, if you want to store your watch definition in a version control system, for example. But we also have a configuration UI, which is based on Kibana, and which I will use mainly in this demo. So if we have a look at the available inputs, of course, Elasticsearch I already mentioned. We also support HTTP and REST endpoint. We do support different types of authentication. So if you want to access an API where you need basic authentication, TLS client certificates or JSON Web Tokens. This is supported in Signals. As I already mentioned, all data is stored in memory in the so-called runtime context in JSON format. And each check and each actions have access to the data in the runtime context. So you can use painless scripts to work with the data. And the scripts can be either defined inline or they can be stored. So the calculations and transformations are basically used for formatting, for combining data, for calculating new data and things like that. Actions define what to do with the results. So you can send alerts, you can store data, and regarding alerts, you can use email, Slack, webhooks, PagerDuty, and we will also support Jira, which is coming soon. Probably not included in the first beta release, but we're working on that. And you can use Elasticsearch and webhooks to store your actual data. Let's get that for a moment. So this was just the introduction. So I'd like to jump in right away and use the rest of the webinar for actually showcasing a couple of use cases in Signals. Okay. So like I said, we do support, or we do have a Kibana UI for Signals. So at the moment, I'm logged in as admin in Kibana. And down here, you can see a new icon, which you can use to enter Signals. So this is the main screen for Signals, which is divided into 3 different sections. The dashboard. The dashboard is used to show you log data about executed watches. And as you can see, I already have one watch running in the background. We have the actual definition of our watches, and we have accounts. In the account section, I have configured 2 different accounts. The first one is an email account. So this can be used for sending out emails as a notification or as an action. Of course, we support TLS, start TLS proxies, and we also support defaults, which is very useful if you, for example, have a default from address where you want to send all the Signals emails from. The defaults can, of course, be overwritten in your individual watch definition. And we also have a debug in the simulate mode, so you can test your email account without actually sending out emails. The second one is a Slack channel. This is pretty easy. This is really just the Slack URL with the actual access token embedded in it. And this is the one that I will use during the demo. So accounts are global objects, which means you can use one account in many different watches and actions. Now let's have a look at, or let's create a first watch. So for this demo, I will use the Kibana sample data. So Kibana comes with 3 different sets of sample data, which is e-commerce orders, sample flight data, and sample web logs. So for the first watch that I'm going to create, I'm using the sample flight data. So let's quickly add it to Kibana. So the flight data is installed. If you have a quick look at the data, how does it look like? Well, it's really just some made up flight data with delay, flight number, flight hour, average ticket price, and stuff like that. And the first example watch that I want to create will operate on the average ticket price. And I want to get a notification once the ticket price falls under a certain threshold. So how can we do that? First of all, I'm switching back to my Signals screen, and I'm going to create a new watch. And for this first one, I'm using an example watch. So Signals comes with some watch examples, which you can install by just clicking at graph or at JSON. The watch examples are based on the sample data, which I just showed, either the e-commerce, the log data, or the sample flight data. And of course, we have a link to a quick documentation, which links back to our Git repository, where you can also see the watches in their JSON format. So I'm going to add it as a graph watch. And now I have the new watch available here. And let's have a look how that looks like. So the first section up here defines the trigger. We have different modes. So you can define a trigger by interval, which would be every n minutes or hours or days or weeks. You can also let it run daily at a specific time. And we also have Timezone Support, which is especially useful if you're implementing watches for clusters in different time zones or locations. We can have a weekly trigger and, for example, define we want to execute the watch every week, Wednesday and Friday at 12 a.m., for example. And if you need some more sophisticated schedule, we also do support Cron Expression, which can be as easy or as complex as you need them. So let's execute the watch every 10 seconds. And in my second section down here, this is actually my watch definition. So as you see, I'm in graph mode at the moment, which is useful for implementing watches without having to deal with JSON at all. So this is just a kind of a point and click definition of a watch. So in my example, I want to operate on the Kibana data flight, sample data flights index. I could add more indices here, of course. In the next section, I have to define my time field. And now I can actually define my, my match condition. So in the graph below, the bluish line, this is the actual data that I pulled in from the index. And the red line is the threshold that I have defined. So we have several aggregations here. So I can choose to have an average count, sum, min, or max value. In my next section, I just define the field I want to work with. So could be average ticket price. It could be something like distance in kilometers. And you can see that we have a live update feature here. So you can actually see, let's have an average here. You can actually see the data as you play around with a match condition. So in my example, what I want to do is I'm going to get the minimum of the ticket price over all documents for the last 1 hour. And I want to get an alert once that is below a certain threshold. So let's say below 500. And I'm choosing 500 here just to make sure that the watch actually fires. Could also use a lower value like this. And let's keep it at 500. And as an action, I want to get a Slack notification. So in the sample watch, there's also a sample Slack output. But since I already defined an account for this webinar, I'd like to use that one. And I want to keep the notification text. So let's delete a sample. And let's add our real Slack. So here I can select the account, webinar channel. If I want, I can also have an emoji. And down here, I have the actual the text of my notification. So you can see here that I can use placeholders here. This is Mustache. So you can use Mustache to insert variables, but you can also do some more complicated or some more advanced stuff like looping over results and stuff like that. So Mustache is the main way to actually format messages, which applies to all types that we have. So you use Mustache for in your email action, in your Slack action, in your webhook action. Now, we can also see in the preview how it would look like. So the mustache variable is replaced by the actual value of my Elasticsearch query. Now everything looks good. Now we have set the watch to active. And when we update the watch, then we should see the actual Slack notification here. So this is my demo Slack channel. And you can see exactly, this is exactly what we expected. So we have 2 Slack notifications here. Now, since we execute the watch every, I think, 10 seconds, this can become quite a lot of information. So one feature you can use to control how many notifications you want to get is the throttling. So we can set it here. So let's say you execute your watch every 10 seconds, but you want to actually have a real notification only every, let's say, hour. So you can set it here and save it. And this will kind of suppress notifications and send out notifications only once per hour. Another way of working with notifications would be to acknowledge a watch, which basically means that you're basically telling signals that, okay, I've seen the notification, someone's taking care about the issue. Please don't send any notification unless the system is back to normal again. Now, this is all well and good, but we want to do some more advanced stuff here. And for the next use case, I'm using the same basic watch definition, but I'm using a so-called block mode. Now, let's have a quick look what that looks like. So I'm going back here and I'm switching to blocks. And blocks basically displays you all the different steps that a watch is going to execute. So in this first example, this is pretty easy. I only have 2 blocks. The first one is the actual search, where we do an Elasticsearch query and aggregate some data. The second one is a condition, and the execution flow only continues if this condition is met, and that's basically it. And then we have our action. So let's use the same block mode to examine a slightly more sophisticated watch. And this is this one here. So again, we're operating on the flight data, but I have a couple of more blocks here. So the first one is the so-called constants. And by the way, in order to add new blocks, we have the add button here. And for all supported types of blocks, we have samples. So we have our inputs here, which could be an HTTP input, which could be a full text search, which could be bucket aggregation, for example. We have templates for condition and transform and calculation scripts. And we have also a static block, which is used to add constants to a watch definition. So I can use the add button to add them to my actual definition here. And I can also use drag and drop, dragging that one here. I can use drag and drop to actually change the order of my different blocks in my watch definition. So I've added 2 or 3 new blocks. The first one is the static block, which is just defining some constants, which I can use then later on in my other blocks. I have my ticket prices. This is the same as before. As a next step, I'm fetching in some currency conversion data from a publicly available API. So let's see how that looks like. Up here, we have 2 buttons, which we can use to actually execute the different blocks. I can either execute only this block or this block and all the blocks above. And if we do that, we can see the actual result. So I have the result of my aggregation. which has at the moment a value of 102. And in addition, you can see here, I've pulled in these exchange rate. This is the result of this, of this API call here to the exchange rates API. And as you can also see here, we define a so-called target with the name exchange rates. And this is where I can find my actual data later on in my runtime context. Now, I've also added a calculation at this point here, and I use that calculation to, well, actually it's pretty simple. I'm just doing some round function on my initial value, and I'm just multiplying the initial value with my exchange rates in euro and round that too. And I'm adding that under two new items on two new keys here, rounded average US dollar and rounded average euro. So these are the two additions. Again, I have my condition, which only fires if the aggregated value is below my defined threshold. And if I execute it here, we can see the complete result. First of all, as JSON. So you can see I have my rounded average here in my runtime data, and I have the converted field rounded average euro in my runtime data here. And now I can use this to actually send a Slack notification. And of course, I can use some formatting here as well. So this message here just pulls in the rounded average data in dollar and euro and sends a Slack message. Let's see how that looks like. Let's activate the watch again and execute it. Okay, so this is the alert that I got. So this is the price alert regarding my now converted US dollar and euro prices. So this is how you actually work with data. This is a pretty straightforward use case. So we did an Elasticsearch query aggregation. We defined some conditions, some threshold. We defined another HTTP input, which pulled in currency conversion data. And we used a calculation to calculate the euro value based on the US dollar value and the exchange rates that we put in our REST API. So that would be a very basic watch example, but that's of course not all that you can do with signals. So another use case could be monitoring. Basically, signals can be used for any periodic job that you need to execute on data that's stored in Elasticsearch or elsewhere. And since we're supporting HTTP inputs, I can, of course, also pull in data from my Elasticsearch cluster or a remote Elasticsearch cluster as well. So let's have a look at this. First of all, let's just deactivate the watch that we just used and have a look at the memory consumption watch here. And again, this is a very, very easy and straightforward watch. It's running every 10 seconds, and it just consists of one input, which fetches the cluster statistics from my current Elasticsearch cluster. I haven't defined any condition here. Conditions, of course, are completely optional. So this watch is just executed every 10 seconds and fetches the cluster stats from my Elasticsearch cluster. Since my cluster is protected with SearchGuard, of course, I will need to provide some credentials. In this case, again, just for the sake of simplicity, I'm using the admin user here. And in my section down here, TLS, I can either define that I want to trust all the all TLS certificates, which of course is not a good thing in production. Just used it here for the sake of the demo. But of course, I can also provide one or more root certificates here, which the other certificates are then validated against. So this is pretty straightforward. And now the only thing that I actually do is in my action. And this is an action now that writes data back to an Elasticsearch index. The only thing I'm going to do is I'm formatting the data that I pulled in into a format that I later want to use with some dashboard, for example. So I just need to provide my index name, which is cluster memory at this point. And then I can use all the blocks that I can use here in my watch definition. I can use all those blocks also in my action. And now this is a very interesting and neat way of formatting data specific to actions, for example. Or what I could do as well is I could use a condition in an action here. But this is some advanced stuff that I will explain in a second. So the only thing that this format script does is it emits a very basic data structure as JSON, where I use a timestamp. So this execution time comes from my watch metadata. So whenever a watch is executed, you have access to some metadata, like when the watch was scheduled, when it was executed, the user that executed the watch, and so on. And the only 3 fields that I'm writing back to Elasticsearch is used memory, free memory, and % used. So the first one are available from the Elasticsearch cluster stats. And the last one is just calculating the percentage value. So this data is now written back to my Elasticsearch index. Let's have a look at the index. It's called cluster memory. And again, just have 3 values that we calculated and a timestamp. Now, what can I do with that? Well, for example, I can use it for actual Elasticsearch monitoring. So we can create visualizations and dashboards that now operate on this data. So I've prepared a demo, and I just import visualizations and dashboards. So let's import that. Okay. And if I go back to the dashboards, then I can see the actual memory consumption. Let's go back to, let's say, last 1 hour. And now I can use the built-in Kibana visualizations, dashboards. I can also use it in Canvas, of course. And I can, zoom in to this data, certain time range, and then have my individual values here. This is just a quick example on how to implement monitoring with signals. Of course, in a real-life scenario, you would probably monitor not only the cluster status, but the node status as well. But the interesting thing is that now you're not only able to, record data and write it back to Elasticsearch. You can also implement watches and notifications, which, for example, would send out a notification if the memory consumption is high, like in this case, 95%. So you could add a Slack or an email notification as well. So this would be just an example of, just by pulling in some statistical data from or health data from Elasticsearch, I can set up my health dashboard and visualizations pretty easily. So the next example is a little bit more complicated, and I use it to show how flexible actions can be. And for this watch, we're looking at some fake log data from a fictitious system. So just imagine that you pull in log data from various systems, and in our case, the log data will look like that. So we have a tool that runs in the background and just generates some, random log data and indexes it in Elasticsearch. So this could be any log index that you maintain in Elasticsearch. The interesting thing is the hash value here, which we calculated. Can calculate it, for example, by using Logstash or Beats or whatever tool you use to pull in log data to Elasticsearch. And we have two watches for this demo, logs to Jira and logs to Slack. What we actually want to implement is we want to monitor our log file, and whenever we see a new exception that haven't been seen before, then we want to create a Jira issue. Whenever we see an increase in the actual rate of one or more of these exceptions, we want to add that as a comment to the Jira issue. And we also want to get notifications on Slack about new issues that we detected, and we want to get notified whenever we see a spike in a certain exception. So I won't go into every detail of this watch, but what it basically does, it's implements some checks and queries which aggregate on the log data, especially on the hash value that I just shown. So the actual check is also really straightforward. We only have like 3 definitions here, and the actual magic is happening in the action. Like I said, you can, in the action section, you can use all the goodies like transformations, calculations that you can use up here. So we've set up 2 actions. One is for detecting new exceptions and to create the actual issue in Jira. Yeah, like I said, it's just some aggregation around the hash value of the data that we have. And the second one is for existing exception, which then would calculate an error rate by using calculations and some conditions. And whenever we detect an increase of 20%, then we will post an issue, a comment to Jira. And again, we used HTTP webhook here to post or use the API of Jira. So let's activate this watch, already set to active. And the second one, this is now pretty simple. This just posts to Slack. And again, this just does some calculations regarding error rates and then decides what the text should actually look like. So let's set this to active again. And for this demo, I have at the moment an empty board in Jira. And of course, I have my Slack notifications, which I've shown already. And if we now start our tool, which is called mocklog, which generates the exceptions in my actual index. Now, since the watch runs every 10 or 15 seconds, it will take a little bit of time until we see something. Okay. Now we've seen that our watch actually has created issues in Jira. If we have a look at one specific issue in Jira here, then you will see we have the hash value, we have calculated an error rate. And at the moment, these are, I think, 10 different exceptions that we actually generate. So yeah, this is that. And in addition to my Jira issues, I can see now here my notifications, and I have set the throttling and the values in the watch definition so that we already see a couple of these issues. For a production system, you would probably generate less of those issues. But here I can already see that I have an issue. This is an already existing issue, SD167, and this now has an increased incident rate. So if I go back to Jira, I can see here that the error rate has increased by 35%. So the watch definition has added that as a comment to my to the Jira issue. And if we now simulate a real spike, and I'm now just creating additional issues at a much higher rate as before. And again, this will take a little while until the errors are actually fetched and aggregated by signals. And these errors should then pop up here as a new type of notification. So you can see here, this has a high error rate, 67%, 70%. So I can use that to detect spikes in specific exceptions in my log file. So you can stop that again. So this is an example on how to use the signals features to do some more advanced calculations like error rates on a live system. And depending on the error rate and the increase or decrease of the error rate, we can send different notifications to different channels. In our case, we created Jira issues and we used Slack to as a secondary notification channel. So and this also demonstrates that we have the possibility of adding as many actions to my watch as we need. So you can just use one notification. You can use 2, 3, 5, or even more notifications. So this is a very flexible way of posting to different channels. Now the last one that I want to show very, very quickly is just some advanced aggregation. And this is to showcase how signals can be used and to integrate with the other SearchGuard features, in this case, the audit logging. So the audit logging is a way to monitor what's actually going on in your Elasticsearch cluster and detect events. So I'm going to add an index pattern for my audit log index very quickly. And in this example here, I would like to monitor failed login attempts. Again, I have a little script that I'm going to start right here. And this is just creating for different accounts just failed login attempts. So in my on my dashboard, the raw data looks like that. So what we track here is first of all the category, it's failed login. The effective user is relevant. The IP address we track, and of course also the time and some additional information like request headers or the node name and stuff like that. Now I can use that again in signals, and the watch that I have created for this example is just uses a little bit more advanced aggregations. So I'm aggregating here over the user and the remote address. I also have a limiting filter, so I just want to have a notification, or sorry, an aggregation if the number of failed login counts is greater than 5 in this case within the last 5 minutes. And in my Slack action that I created here, or maybe first of all, we can have a look at how the data looks like. Now we have our buckets here on the right side with the document code, with the IP address, with the actual name of the account. And I can use that to add a little bit more mustache magic here. So this is a message, and as you can see here, this is a simple loop in mustache where I'm just iterating over the failed login buckets that are aggregated before. And again, if I execute this one here, we need to set it to active. Yeah. Then again, I'm getting a respective Slack notification. And now I have my aggregation here, and I can see which accounts are affected. You could now also pull in, for example, some geographical information based on the IP address by using a geolocation API, for example. You could also implement a watch which fires if you have logins from different IP addresses from different locations. So this is really just a basic example on what you can do regarding security monitoring. Okay, so now just as an outlook, So we have two features that are not finished yet, but which are scheduled for our beta. The first one are severity levels. So you can use it to define severity levels like error, critical, warning, and then use these severity levels to trigger the actions. This is more of a traditional model of defining when an action should actually fire and send a notification. And you can also implement escalation levels with that. So for example, you can say that for every error, you would like to send out an email to someone on duty. But if the error message goes from, if the severity goes from error to critical, you would like to send a Slack message in addition. Next one are resolve actions. Also scheduled for beta. This is basically a way of saying of getting a notification once your threshold is not met. So kind of if a system moves to a critical status and then moves back to normal again, you can send out another message saying exactly that. For example, the error rate in the log files was high, but has now dropped below 20% again. So this is scheduled for beta as well. Of course, Signals is integrated with all security features like role-based access control, document feed level security, and multi-tenancy. The security is also applied to the execution context of the watch. This means that a watch always runs in a specific security context. And in this case, it's the security context, means the permissions that the user that created the watch has. Regarding administration, of course, you can configure all the index name. That's kind of a no-brainer. You can also control on which nodes Signals should run. So if you have a lot of watches and you don't want to run them on all the nodes that you have in your cluster, you can define that, for example, Signals should just run on 2 or 3 nodes. Of course, if a node goes down, we have an automatic rebalancing of our watches. So the watches that have been run on the broken node are then re-shifted to another running node. And we will implement Signals health checks, which will provide an easy way to see if a watch, for example, is constantly failing because you have an error in your script, for example, and also a way to monitor long-running watches. So, for example, I don't know, you have an Elasticsearch query, which is not very performant, then you can also see that very quickly and fix it. Regarding the roadmap, the technical preview version 3 is already available. This is on our documentation and the versions page. You can find all the download links. It's on version Elastic 7.4.0 at the moment. And we're actually nearing the official beta of Signals, which is scheduled for the 16th of December. And the GA release will be in January 2020. Like I said, Signals will be integrated and shipped with SearchGuard, which means it will be a single download. So you don't need to install and maintain a second plugin. So it's just one install. This is true for the Elasticsearch plugin and also for the Kibana plugin. Of course, if you don't need Signals, you can turn it off and it will have no effect on your runtime performance, but it will just be one package. Regarding the license, I think I already mentioned that we will will ship a totally free community edition, which will include everything that you just saw in this demo. So these features are completely free for you to use. And then we will add some more sophisticated features on top of that, which we will then ship with the enterprise version of Signals. Regarding the licensing, we will include the Signals license in all SearchGuard licenses, which means that if you're already an enterprise customer, well, you will basically get Signals for free with all the enterprise features included. So that's on top of the SearchGuard security features. So that's it for the quick demo. And now we can have a quick look on the questions section. So we have a couple of questions here. So the first one is, could we control watches via YAML in a similar way we deal with users and roles? Well, at the moment, we only support JSON, but what we are thinking about and what we will likely be shipping are so-called importers. So we'll make it very easy to import watches that you created, for example, with XPack alerting, or with Elastalert, or with other tools. And by doing that, we could also define a format regarding YAML. The next question, do the watches show up as saved objects which can be partitioned per space? Actually, no, because saved objects and spaces are Elasticsearch basic license features. They're not even included in the OSS version. So you can't partition them with spaces, but you can, of course, partition them with SearchGuard multi-tenancy, which means if you're activating multi-tenancy, that means a watch is created per tenant, and then you can grant role-based access to those tenants to your users. So like multi-tenancy, which I think we implemented in 5.0 something, and spaces, which came with 6.4, I think, are very similar. So in our case, in the SearchGuard case, you would probably use multi-tenancy for doing that. So the next question is, do these watches support impersonation as in they are executed as the same user who created it? Yes, this is the main concept behind it. So when I talked about a security context, that means whenever a user creates a watch, then we will attach the user's security context, which is basically the user's permissions at that point in time when the user created the watch. So the watches are not run as admin or super user, something like that, by Signals, but they're actually run as the user that created it. Which of course also means that when another user is changing some parts of the watch and save the watch, then the security context will be overridden by the second user's security context. So next question, with a compliance version, will we get the Signals Enterprise? Yes, of course. So for each SearchGuard Enterprise and of course each SearchGuard compliance license, Signals Enterprise will be included and completely free. Okay, so that's for the questions. I don't think we have any more. Okay, so last one came in. Is there throttling to avoid too many notifications? Yes, of course. So we have the standard throttling, where you can define that you only want to have a notification each, I don't know, minute. And as on top of that, we also have exponential throttling, which would mean that the first notification would be sent, let's say, after 2 minutes, the second one after 4, the third one after 8, and so on. And of course, you can define your exponent here as you like. So you can implement own kind of throttling schedule. This will also be available in the Signals beta already. Okay. So since we don't have any more questions, the only thing for me left is to thank you for attending the webinar, and hopefully you will try out Signals on your own. We're always very grateful for any feedback, positive and negative. So just give Signals a spin. If you find anything positive or negative, either drop us an email or just use our forum or send a tweet or something like that, so we can integrate your feedback into the GA or the next releases of Signals. So the webinar is then also available as a video if you want to re-watch it or send it to a colleague or coworker, and we will send out the respective video URL shortly. So thanks very much for your time, and yeah, see you soon. Thanks very much. Bye bye.